Hello, in this video, I will be talking about the basics of hypothesis testing. Let's go over a few definitions. We will learn about the elements of a hypothesis test, and we will put all of those together, going through some examples. Hypothesis testing is a decision-making process. Specifically, it is a way of evaluating claims about an unknown population parameter. In this chapter, we will look at the mean and proportion. And later on, we will be doing hypothesis tests for the standard deviation and variance. Now, in the previous chapter, we were able to estimate the mean and the proportion. We were able to create confidence interval. And that was the first part of inferential statistics. Now, we will be able to actually look at claims and evaluate claims through this process of hypothesis testing. So hypothesis testing is actually a process that uses the sample statistics to test a claim about the value of a population parameter. And this is what we've done in the past. And we were looking at sample statistics even in the confidence interval chapter, trying to find the confidence interval for the population parameter. In this case, we will actually test a claim about the population parameter. So everything in statistics starts with the sample statistics, and the idea is to get as closer as we get to the parameter, or in this case, to test claims about the parameter. When we test a claim about the mean, then we use the sample statistics X bar. We've seen before that if we test a claim about the proportion, we will start at P hat. Okay, so let's just try to get the idea of what we are doing before giving any more definitions. And here is this example. Let's just say that an automobile manufacturer advertises that its new hybrid car has a mean mileage of 50 miles per gallon. To test this claim, a sample will be taken. If the sample mean differs enough from the advertised mean, you can decide the advertisement is wrong. So let's see. You don't believe this advertisement. What will you do? You will take a sample and find the sample mean. So let's just say someone actually did that. And these are the results from the sample. Let's just say from the sample, and the sample was 30 cars. X bar, which is the sample mean, happens to be 47, and the standard deviation, and let's just say we know the standard deviation sigma, and that will be 5.5. Okay? Now, if the sample mean differs enough from the advertised mean, this is the sample mean. So think about it. This is the advertised mean. What do we mean by enough? We may wonder, okay, you know what? For some people, this will not be an enough difference to decide that the advertisement is wrong. For some people, this will be enough difference to decide the advertisement is wrong. And that's why we have to do some calculations and try to quantify this idea. What is this enough? So let's work on this. And this is what we will do. Let's just assume that the advertisement is correct. And this is at the heart of hypothesis testing. Assume, in this case, the advertisement is correct. In other words, let's just assume that the mean is indeed 50 miles per gallon. In other words, we are giving it the benefit of the doubt. Then, let's try to find the probability of getting a sample like the one that we got. So we will examine the sampling distribution of the means and find probability of getting this sample, that from samples of 30, we will get a mean of 47. So what is actually the probability that X bar is 47 or even less than that? So we will try to figure this out. Can we figure this out? Well, yes, because from the central limit theorem, we know that the sampling distribution of the means, and I will sketch the graph right here, follows a normal distribution. And we know that the mean is the same as mu. And we're wondering, what is this probability? X is less than or equal to 47. What is the probability that we will get such a result if the advertisement is correct? If the mean is actually 50 miles per gallon. Do we know how to find this? Yes, we do. So I just simplify probability that X bar is less than or equal to 47. So 47 or less. It's actually normal CDF from negative infinity to 47 when the mean is 50 and the standard deviation is 5.5 divided by square root of 30, right? We have the standard deviation given right here. So in this case, we do realize that the probability of getting a value as extreme or even more extreme than the one from the sample, it's 0.0013. It's a very small chance. What does this mean? This means that this is an unusual event. So now coming back to what does this mean? We actually have two options. And these are the two options. Let's just say that the mean is actually 50 and a very rare event has occurred. The second option is the mean is not 50. If this happened, the mean is not 50. Think of this. Which one is more plausible out of these two? So think of if the mean is actually 50 and you take more samples and more samples and more samples, you will not have this result. You should not have this result. This just happened to be a very rare event and has occurred once. But the next 30 cars you take and you figure out the X bar will have something close to 50, right? Or it's just that the mean, the second option, which is, well, we assume the advertisement was correct. We did all of this work, but if this happened, the advertisement is not correct. So out of these two options, actually the second one is more plausible, most likely. The advertisement is false advertisement. Okay, so this is actually an example of hypothesis test. However, we have a step-by-step process. We have a set of new terms that we will learn, and then we will go over the examples. And in this chapter, we will do hypothesis testing for the mean and the proportion. So let's take a look at the general idea of the 5 steps of hypothesis testing. You will see this in different textbooks as 7 steps. We're trying to put this together into a 5-step process. So here we have step 1, state the hypothesis, which we call the null hypothesis and the alternative hypothesis, and identify the claim being tested. We will talk about these 2 terms. We will define what is that the null hypothesis, what is that the alternative hypothesis, and how do we identify the claim. That's the first step. Step 2, select the appropriate sampling distribution to perform the calculations. At this point, we learn about the Z distribution or the T distribution. And there are more. We'll learn about other distributions later. But you need to know exactly which one to use. And you will know because based on the parameter we are testing and based on the conditions given, we should be able to identify which one of the distributions to use in order to perform the calculations. Step 3, we will always assume that the null hypothesis is true. This is essential. And then we calculate the probability of getting sample data like the data we have actually observed. This is what we've done in our previous example. Step 4, if this probability is sufficiently small, and we will learn what that means, we will quantify this, then we will say we reject the null hypothesis. And then we want to make sure we interpret the results by writing down a meaningful English phrase. Let's take a look at what the hypotheses are, because that's how you should always start an hypothesis test. A statement or a claim about a population parameter is what we call a hypothesis, a statement or a claim. In an hypothesis test, we need actually 2 hypotheses. one that represents the claim, and the other one will be its complement. One of these is false, the other one is true. We call this the null hypothesis and the alternative hypothesis. What is the null hypothesis? A statistical hypothesis that contains the statements of equality, such as less than or equal to, or greater than or equal to. It is denoted H sub 0 or H naught. The alternative hypothesis is a statement of inequality. This will be strict inequality. That means it doesn't have the equal sign in it. Look at this, greater than, not equal to, less than. This is the hypothesis we go with if H sub 0 is false. It is denoted H sub A, and in some statistical books, you may see H sub 1. This is also a notation used for the alternative hypothesis. So the first step in any hypothesis test type of problem will be to identify these two hypotheses. For that reason, let's practice. Write a claim as a mathematical sentence. State the null and alternative hypothesis and identify which represents the claim. A car dealership announces that the mean time for an oil change is less than 15 minutes. Before writing down the hypothesis, translate this information into mathematic symbols, into inequality symbols. Mean time, less than 15 minutes. And you can put the unit measures just to make more sense. And then write down the hypothesis. And I'll write down the hypothesis as a pair, always starting with H sub 0, followed by H sub A. And I'll use capital A to make the distinctions between the 0 and A. Now, I look at what I already wrote down based on the given information. The mean is less than 15 minutes. And I'm wondering which one of these two is actually this inequality. Because it's strict inequality, this one will actually be the alternative hypothesis, which means mu is less than 15 minutes. The other hypothesis, which is the null hypothesis, will be the complement of this one, which means greater than or equal to 15 minutes. Now, the claim in this case, it's actually based on the word announces. The car dealership announces this, which means this will be the claim. Look for this type of expression. If you can change this into a car dealership claims that the mean is this, that it makes sense, that will be the claim. So I will simply write down, this is the claim, which is the second one. Keep in mind, the claim can be the first one or the second one. In this case, it is the second one. And this is how the null and alternative hypothesis look like. Something else about the notation. If you look some other statistical textbooks, you may see H sub 0, and I write right here the alternative, 15 minutes, and H sub A as mu is less than 15 minutes. Okay, and why would you see this? And this will still be correct. You do realize that there is a difference right here. Right here we have greater than or equal, and right here we have only equal. Because as long as we have the alternative correct, all it matters in the null hypothesis is the equality. All you actually look at in the null hypothesis is the equality. So if you see this in a different textbook or another textbook, it is still correct. It's just a notation. Let's just take a look at the next example. A company advertises that the mean life at its furnaces is more than 18 years. So before jumping into writing down the hypothesis, I'll simply translate this mean life, which is mu, more than 18 years. Again, I see that this is actually strict inequality. So I will go ahead and write down this H sub 0 first, H sub A first, and I'll be looking at what is this? Is this a strict inequality or it includes the equal sign? Well, this is strict inequality. So the strict inequality always goes into the alternative hypothesis, which makes this null hypothesis opposite, less than, and equal. Equal is very important. And we will use the same number of which one is the claim. Advertises, this is what they advertise. So this will be the claim. So in this case, again, the claim is the second hypothesis, which is the alternative hypothesis. Make sure you know that not all the time that will be the claim. For this example and for the previous example, the alternative hypothesis was the claim. Now let's just take a look at the next example. For the next example, it says, a school publicizes that the proportion of its students who are involved in at least one extracurriculum activity is 61%. Read the problem carefully and make sure you know which one is the parameter that is in the problem. Proportion who are involved in at least one is 61%. This is a little bit tricky because students tend to focus on this, especially because we've done so many problems with this expression. However, if you read it carefully, this is about proportion being 61%, okay? So I will translate this as P equals 0.61 proportion. This time, the claim is about proportion, and it's an equality. So to write down the null hypothesis and the alternative hypothesis, since I see this one contains the equal symbol, this one will actually become the null hypothesis. The complement of this one will actually be not equal to 0.61. And which one will be the claim? Well, the school publicizes this, which means this time H sub 0 is the claim. And this is the first step that you do when you start the process of hypothesis testing. Of course, it requires some practice. And after a lot of practice, you will see that this is not very challenging. So let's continue with more definitions. Here is the basic idea. We start by assuming that the null hypothesis is true. Then, based on the assumptions, we calculate the probability of getting a sample like the one in hand. If this probability is sufficiently small, then it is interpreted as evidence that the assumption is false. In other words, a small p-value is evidence against the null hypothesis. And this is exactly what we've done using the previous example. So let's see. How do we set up the test? As I said, the test or every test will be a step-by-step process. After stating the hypothesis, the researcher's next step is to design the study. The researcher selects the correct statistical test, and we'll learn about how to do that. This will depend on the nature of the hypothesis, the sample data, and the parameter being tested. So these are the three things that will determine the statistical test: the nature, the sample data, and the parameter being tested. We need to know exactly what type of test we are doing, and we'll talk about the nature of the test later. The sample data, we need to know what information we have from the data and what parameter are we testing. The next step will be to choose an appropriate level of significance. So what is that, a level of significance? Well, the level of significance is what we call alpha, and we use alpha, we use this notation when we talked about confidence level, and alpha is actually the maximum probability we will allow before rejecting the null hypothesis. It is a probability. It is the area under the curve. It is the cut-off value, okay? The significance level is depending on the nature of the data and the consequences of making incorrect decisions. So even if we are doing a test, we can make errors. There is room for error. And we will be talking about the type of errors we will make while doing a hypothesis test later. But for now, we are focusing on the level of significance, which is the maximum probability we allow before rejecting the null hypothesis. That's how we will answer the questions. What is that enough? This is how we quantify that type of question that we had for our first example. What do we mean by a value being enough? Generally, alpha will be given to us. Now, if it's not given, we choose alpha. The most common value is 0.05. It really depends on the type of test. If we are doing social sciences type of test, alpha can be 0.10. If we are doing pharmaceutical industry type of test, then we want a small alpha. We want to minimize possibility of making an error. Commonly used, though, it's 0.05. Okay, what is that, the p-value? The p-value of a test is the probability of getting a sample statistic, such as the mean, or a more extreme sample statistic in the direction of the alternative hypothesis under the assumption that the null hypothesis is true. So the p-value will actually be an area under the curve, right? And it's actually the area that we found when we used the central limit theorem in our first example in this video. That was actually the p-value. So it is the probability of getting the sample statistic, and sometimes we use the mean, sometimes we will use the proportion, and sometimes we'll use some other statistic. But we are looking at the probability of getting that value or even a more extreme value in the direction of the alternative hypothesis under the assumption that the null hypothesis is true. Of course, this probability can be thought as an area under a portion of an appropriate probability distribution. So again, for this type of problem, we will sketch the graph as we did in our previous example, and I will quickly sketch the graph right here. We had X bar, we had the mean being 50, and we were looking for probability of 47 or less. That was our first example, and we found that probability using the central limit theorem. So that was actually what we referred to as the p-value, and we decided that was too small, and because of that we had enough evidence to reject the null hypothesis. So what do we do after we find the p-value? Well, I just said we will reject the null hypothesis if the p-value is less than the level of significance. So if the p-value is less than the level of significance, and right here for different textbooks you may see less than or equal than alpha, that should be alpha. Okay, that's also correct. It is very rarely when it is equal to alpha. The type of language we use here is reject, or do not reject, or fail to reject. And I know that's a lot, but something else that I want to point out is the fact that it's always about H sub 0. You will never say, I reject H sub A or the alternative hypothesis. You will say, I reject H sub 0, or I do not reject H sub 0, or fail to reject H sub 0. You will also not say, I accept H sub 0, because there is a possibility that we've done some mistakes. And actually, there are type of errors that can occur. So if P is less than or equal to alpha, we reject H sub 0. If it's greater than alpha, we do not reject H sub 0. Now, to put this in context, we will need to interpret. This is how you will need to make sense of what we've done. For every test, you'll have to write down an English phrase in the context of the problem, and maybe this will help you. It really depends on your decision to reject or fail to reject the null hypothesis, and also on which one is the claim. If the claim is the null hypothesis, you'll have to say there is enough evidence to reject the claim when you reject the claim. If the claim is the alternative hypothesis, you will say there is enough evidence to support the claim. What I want to point out here is the fact that when you decide to reject H sub 0, you should always start with there is enough evidence. There is enough evidence, and you should also say at what level of significance. So you will put in at alpha, and you'll put in the number corresponding to alpha, which is the level of significance. And I want you to practice when we do this type of problems, looking at the table, but at some point, this should make sense because you'll know exactly which one is the claim. And it will make sense that if your decision was to reject H sub 0 and H sub 0 was the claim, of course, this word will be reject. If you made a decision to reject H sub 0 and that was not your claim, then you will support the claim. Now, if you fail to reject H sub 0, you always start with there is not enough evidence. This is how you start, not enough evidence. For me to remember this, I'm looking at, well, I start with a fail. So I will put in the corresponding not, even though this is double negation actually. But a way to remember will be that. And again, rejecting or supporting the claim, depending which one the claim is. Rejecting the null hypothesis means that there is evidence in favor of the alternative hypothesis. On the other hand, failure to reject H sub 0 does not mean that H sub 0 is true. It simply means that the sample data did not provide sufficient evidence to say that H sub 0 is incorrect. Another important part of hypothesis testing is the nature of the test. There are three types of hypothesis tests: left tail test, right tail test, and two-tailed test. The type of the test depends on the region of the sampling distribution that favors a rejection of H sub 0. This region is indicated by the alternative hypothesis. So until now, the alternative hypothesis didn't really have a very important role, or we didn't really see this in this definition. But right now we see how important it is because this alternative hypothesis determine the nature of the test. So if we are doing a test in which we set up the hypothesis and the hypothesis look like this, in order to decide the type of test we are doing, I have to look at this alternative hypothesis. Now, alternative hypothesis has a strict inequality symbol in here. This symbol points to the left, which means this will be a left tail test. So the alternative hypothesis alone determine the nature of the test. When I will do the work and shade the sampling distribution corresponding to the test, and let's just say I'm using the Z distribution, but sometimes we will be using the T distribution, then in order to find values, I will always look at something like this, which is corresponding to a left tail test. The left tail will be the shaded area, and we will have a p-value in the left tail. We will have the corresponding test statistic on the z-axis. On the other hand, if we have a right tail test, then the null and the alternative hypothesis will look like this. You see, the alternative hypothesis, strict inequality pointing to the right, and this is how the visual will look like. The area will be shaded in the right, and that's where we'll have the measures we will have to find. When we're talking about the two-tailed test, and I'm doing this only for the mean, but keep in mind the parameter may change to proportion or standard deviation. The idea stays the same. H sub 0 will be mu equals some number k. H sub a will be mu is not k. This is the one that gives the direction of the test. The distribution associated with it will actually have both tails shaded. And this is actually very similar to what we learned when we talked about the confidence intervals. Now let's take a look at these basic ideas on another example. A researcher claims that the average startup time for all computers of a certain model is below 60 seconds. It is known from a previous study that the standard deviation of startup times for this model is sigma equals 11.2 seconds. Next, she selected 40 computers and timed their startup. It was found that the sample mean was x bar equals 56 seconds. She has decided on a level of significance alpha 0.05. Let's try to construct a hypothesis test around this example. Starting with a basic idea, trying to follow the steps. The most important part is to write down the given information using the proper notation. So right here, she says that she claims that the startup time for all computers is below 60 seconds. I will translate this into mu less than 60 seconds. And you already know at this point that this will be the alternative hypothesis. And then it is known from a previous study that the standard deviation is this value. So sigma is given. Next, she selects 40 such computers, which means N is given, and the sample mean, which is X bar, is 56 seconds, and alpha for this study is 0.05. So what we will attempt to do, we will try to go over the steps, the basic idea of the 5-step method in doing a test, an hypothesis test of this situation. So we will test the startup time, which is the mean. The first step will be state a hypothesis. As I said, this is the alternative hypothesis. So I just write down H sub 0 first, H sub A, strict inequality, it's about the mean, so this will be less than 60 seconds, and mu will be greater than or equal to 60 seconds. Which one is the claim? Well, it says right here that she claims that this is below 60 seconds, so it seems that this one will be the claim. What I also like to do when I do a test like this, I like to write down which one is the nature of the test. What is the nature of the test? The nature of the test, as we learned, is related to this second hypothesis. This one points to the left, so this will be a left-tailed test. Okay, so now how do we find values and try to come up with a p-value? Well, as simple as thinking of the central limit theorem. Since n is greater than 30 and sigma is known, central limit theorem tells us that the sampling distribution is normal, approximately normal. So if I were to actually visualize this, here is my sampling distribution. This is the distribution of X bars. I have 60 right here. And I'm looking for the probability of getting this sample with these results. X bar that we got is 56. The probability we are looking for is actually called the p-value. So we found this p-value right there. Normal CDF from negative infinity to 56, 60, and 11.2, and we got 0.0119. This is the p-value. Since we have the p-value, we can actually make a decision. And the decision will be based on this. Is p-value less than or equal to alpha? If it is, we reject H sub 0. Or if it's more than alpha, we will fail to reject. And again, H sub 0. So let's compare p-value, which is 0.0119, with alpha, which is 0.05. See, alpha is given right here or right there. If it's difficult for you to compare, make sure you have the same number of digits, 4 digits. And now you will see that this is actually smaller. The p-value is smaller than this. So based on that, we will reject H sub 0. Finally, we interpret our decision about H sub 0 to write a specific and meaningful conclusion for the test. Remember, based on our sample data, our decision was to reject H sub 0. This means that we have statistical evidence that H sub A, the other one, the alternative, is true. We have evidence that the mean is less than 60. Therefore, we have statistical evidence that the population mean of all startup times is less than 60 seconds. And I will simply add here at the level of significance 0.05, because if we repeat the test and we put in a different level of significance, this may not be true. We will say that there is enough evidence to support the claim. The claim was H sub A. How do we do these calculations? On the calculator, you can find this type of tests under test. Now, we will talk about different types of tests. You have to make sure you choose the appropriate test to get both the test value or the test statistic and the p-value. For the type of test we just done, because we use the z-distribution, the standard normal, we will be using the z-test. Plug in the corresponding values. So click on test, click on z-test, and then plug in the corresponding value. Make sure you identify the type, the nature of the test. And this was a left-tailed test. And when you hit calculate, you realize that this is the lowercase p, which is actually the p-value. And that's enough to make a decision. However, you will also see that there is a z-score. Now keep in mind, this z-score is the corresponding value of an area of 0.0119 on the left tail. So the z, which is called the test value, the lowercase z, it's actually the corresponding z value right here, which is negative 2.26, corresponding to the p-value, which is 0.0119. This was based on the standard normal distribution. And this is actually the score corresponding to x bar, which is the statistic for that example of 56. And what you see right here is the z-score formula, the value minus the mean divided by the standard error. And that can be calculated, if you wish, with a formula, and it will be negative 2.29. This statistic is called the test value or the test statistic for the hypothesis test. Note that the test statistic completely determines the p-value and vice versa. And the best way to visualize that is by sketching the graph. There will be many more examples. This was just an introduction, and I know you will learn a lot of new terms, and it may be confusing at times, but now the more we get into hypothesis testing and we practice with the 5-step methods, this will become easier. Thank you for watching.